So what is electromagnetic induction? So what is electromagnetism? Electromagnetic induction. It means that from magnetism, electricity is produced. Okay, that's what means by electromagnetic induction. We were talking about this in the previous lecture. Here we have an ammeter, right? I've told you in the last class that we have a north pole and a south pole of a permanent magnet. And when we placed near to this solenoid or a coil, no needle is moving, right? But when we move it towards the coil, this needle shows deflection in one direction. And in the third case, what we have seen, if you move away, right, the needle shows deflection in the other direction, but it should be moving, right? So what we found out is whatever EMF or current induced, we call that EMF or current induced EMF. EMF means voltage or induced current. The one which is produced due to magnetism is called as induced. So this induced current or EMF is directly proportional to the rate of change of magnetic lines cutting the coil. So if you produce a rate, then and only then it will be induced, the induced EMF will be induced in the coil. So I think we have written till somewhere, till where we have written? Yes, Ibrahim?
Till Faraday's law.
No, no, till where we have written actually, I just forgot.
Um, till uh, the reason, like when a magnet is placed near the coil, the rate
Okay,
of
okay.
change
Yeah,
magnetic
yeah,
field line.
okay, okay. I want you to draw the first diagram. If you have done that, then write few lines after drawing the first diagram. When a magnet is placed near to the coil in stationary condition, ammeter doesn't show any deflection. Ammeter doesn't show any deflection. Just write a reason heading is placed near to the coil. When a magnet is placed near to the coil, no ammeter doesn't show any deflection. Ammeter doesn't show any deflection. Now put a heading reason. Since the magnet is in stationary condition, so no rate of change of magnetic lines, cutting the coil produced. So no current is induced. In the coil. Second case. Draw the diagram, please. Okay, write it down. When a magnet is moved towards the coil, ammeter shows reading or ammeter shows a deflection. Ammeter shows deflection at one side. Reason, when magnet is moving towards the coil, rate of change of magnetic lines cutting the conductor or a coil changes in the bracket increases. So current or EMF will be induced in the coil. That is the reason ammeter shows a deflection in one side. That is the reason ammeter shows deflection in one side. Third case. Draw the diagram quickly. When a magnet is moving away from the coil, when the magnet is moving away from the coil, ammeter shows deflection in the opposite direction. Ammeter shows deflection in the opposite direction. Reason: when magnet is moving away from the coil, when magnet is moving away from the coil, rate of change of magnetic lines cutting the coil, rate of change of magnetic lines cutting the coil changes in the bracket reduces, which produce or induce current in the coil. That is the reason ammeter shows deflection in the opposite direction. Ammeter shows deflection in the opposite direction. So students, do you understand that why this happens? Actually, everything happened due to rate of change of magnetic lines of forces cutting the coil. Cutting the coil means the lines which are cutting the magnet. Now, an interesting point. What Faraday law is saying. From this experiment, what Faraday induced is that whatever EMF or voltage which is produced in the coil, so you can say voltage produced in the coil, and we do not call it just a voltage, we called it induced voltage. Induced voltage produced in the coil or induced voltage induced in a coil is directly proportional to the rate of change of magnetic lines cutting the conductor or a coil, right? We also use this magnetic lines which are rate of change, or we also use a word called magnetic flux. Rate of change of magnetic flux as well. Rate of change of magnetic flux. So rate of change of magnetic flux is also used. This is what we called as Faraday law. So what is Faraday law? Just put a heading Faraday law and I will dictate here. Voltage produced or induced, voltage produced or induced in a coil, this is written, is proportional to the rate at which the magnetic field lines are cutting by the conductor. That is what we called as induced EMF concept. Students, any question in this? Now, once you understand that when it goes in the opposite direction, when it goes in the straight direction, now what are the factors at which this induced EMF is depending upon, and how can you increase it? You can increase it by two ways. One is by the strong magnet, or the other one is to increase by number of turns, and the second one is moving the magnet faster. So I want you to put a small quick heading, factors affecting induced current, and write these three quickly. Moving the magnet faster, using a strong magnet, or increasing the turns on the coil. Okay, let's move on. Now remember one thing. My question to you is, how can you produce the change of rate of change of magnetic field? What do you think in the machinery? Will you continuously move the magnet, or you'll move up and down? I mean, bring it closer to the coil and then move it fast away from the coil. Do you do like this? Will that be possible? Yes, Ibrahim, what do you think?
No.
Then how to produce the rate of change of magnetic field? It means that instead of using a DC current, you can use an AC current, because the AC current, I have told you, continuously changing its direction as well as its values. So remember that the input of that type of device will be an AC. So basically, rate of change of magnetism or rate of change of magnet will actually produce a AC. AC means which change with the time, right? So how does it change? Let's see. So AC is a alternating current. The current constantly changes direction. Main electricity AC. So basically, remember that AC means what? The value and the direction of a AC current or AC voltage is increasing or decreasing. That is what we call as AC. While DC, the voltage and the current value will be constant. So remember that this is the mechanism of a generator which I am talking about. In a generator, it always produces an AC voltage because rate of change of magnetic flux or rate of change of magnetic field will be continuously changing. So whenever you see that, you always see AC generator, never ever a DC generator. Now another very interesting fact. This is your basically generator. It's the same thing, 101% same, no difference at all. Shape is same, body is same, except one thing. Instead of input as an electric connection, there is a mechanical connection, or nowadays a gas, what do you call it? Uh, Sui gas is used for that. I mean, not a sui, you can say gas is used as an input. So you give it input as a gas, or you can give your hand, or you can give it a kinetic energy, and you will move this magnetic armature like this. When you move it, it produces an electric energy as basically rate of change of magnetic field rate of change of magnetic field produces an electric energy or electricity at this point, which is a AC. So if I ask you what is the phenomena, you can simply tell me that rate of change of magnetic flux is directly proportional to the EMF produced in the coil. That is what the phenomena of AC generator. And what is AC generator? A generator is a device that converts mechanical energy into electrical energy. Guys, do not need to write it because I'm going very fast. I will provide you the same notes as well. I already provide you the notes. Did you get the notes? Everyone? What is the generator? I want you to just write the definition of it. The generator is a device that converts mechanical energy into electrical energy. And the rest is absolutely same. It's same as a generator. So if they ask you why the electricity is produced in the generator, you will simply tell them Faraday's law. That once the kinetic energy is given to the armature, or once the kinetic energy is provided, the magnetic field is produced, and that magnetic field produces a rate of change of magnetic field which cuts the coil, and so the electricity is produced in the generator as per the Faraday law. Okay, understand? Everybody understand?
Yes.
Okay. Now the same thing, brushes, you have it. Remember that here, instead of saying split ring, we called it slip rings. So there is a small difference between the names. There in AC motors, sorry, DC motors, we give it a name called split ring. Here we called it slip rings. Otherwise, everything is safe. Now, brushes keep the coil connected to the outside part of the circuit. As coil rotates, it cuts the magnetic field, so EMF is generated and current flows. The slip ring keep the coil in contact with the brushes throughout the rotation, and as result, the current flows in the alternating direction and producing an alternating current. I've just told you this is a bit different in here as per in the generators. Okay. Now, interesting fact. Here, if you see that this is the diagram of the AC voltage. Check it out how it changes. With the time it's changing. It reaches to the maximum point. Then with the time it goes down. It goes to the minimum point, then goes up. So what is the AC supply? AC supply is the supply that alter its direction as well as its value per unit time. It continuously changing its value and direction. Okay. Now next, see that at maximum forward current, at minimum reverse current. That is what the machinery will does. All is written here. So I just want you to just understand that. Okay.
Sorry, I
And
can't hear you.
yeah, can't hear you.
Hello.
Hello. Can you hear me? Hello.
Now I can. Can you
Okay.
repeat, please, sir?
See, what I'm saying is once the value is reaching to the maximum point, right? Now, what I was saying is, let's see. So these are the things which can maximize the EMF. So how to do this? Number of turns, if you increase it, area of a coil, increase it, or you can use the stronger magnets. Same thing you do, and you will get the maximum magnetism or maximum voltage at output. Okay. Now, what I wanted to say here, when the current reaches to this point, that is per the rotation actually. At this point, you got a maximum. It means the current is actually in the forward direction. And when you reach here, the current will be in the reverse direction because it's just a motor. So the direction of a current changes. So upward means positive direction. Here means reverse direction. Okay. I'll send you this PPT so that you can go through that. Now here. So the point is, this is called your transformer. Now, can you see a transformer that there are two coils in it? One side of the coil is called as input coil, or you can say primary coil. And the other side is called as secondary coil. Check it out. So remember that a transformer has two coils. One coil is input coil, that is primary, and one coil is called as output coil, or which is called as secondary coil. Now, what is actually happening here? When you provide an input AC, it produces a rate of change of magnetic field. Now, how to produce a rate? Because the current is alternating and it changes with the time as well. So, because the current is changing with the time, so magnetism produced in the coil also changing with the time. This changing with the time also associated with the secondary because it's continuously changing. So, at output, you will get a voltage, and that is what the phenomena of a transformer which we used. There are two type of transformers we have. One transformer is called as step up transformer, and one type of transformer is called as step down transformer. One transformer is used to increase the voltage, and one is used to reduce the voltage. Increase and reduce. Now, my question to you is, guys, I told you previously, if you remember that in our house, all the devices or mostly all the devices are DC supplies or DC operated. Like your television is a DC operated one. But my question is, Ibrahim, are you providing your TV a DC supply or a AC supply? Yes,
An AC supply?
an AC supply. The question is, first of all, remember another thing. Your TV is operated at 12 volt. My question to you is, you are providing 240 AC. How do this 240 converted into 12 volt? Ibrahim, what do you think?
Sir, I don't understand question.
My question is, you are giving 240 voltage, right? Direct from the main supply, your TV. But if you read at the back of your TV, it's written 12 volts. So the battery inbuilt in your television is 12 volt. My question to you is, when you're providing 240, if it's written 12 volt, it means your TV is operated at 12 volt. My question to you is, which device is converting 240 volts into 12 volt? The device is called as a step down transformer. What it does, it changes 240 AC into 12 volt AC. Then this AC will be converted into DC inside your television, and then your TV will be operated at DC volts. Now, do you understand what I did say? What did I say? Yes, Ibrahim.
Yes.
So basically, the transformer which is used in televisions, the transformer which is used everywhere, wherever you have to reduce the voltage and then you have to operate it on a DC, all the places you use this transformer. So put a heading transformer first. Transformer. Transformer is a device which is used to step up or step down the voltage. Step up or step down the voltage. It means that there are two type of transformer. One transformer is called a step up transformers, and one is called as a step down transformer. Put a heading step up transformer. Step up transformer. Step up transformer is the one. Step up transformer is the one which is used to increase which is used to increase the voltage at the output, which is used to increase the voltage at the output. Then put a heading step down transformer. Step down transformer. It is the transformer which is used to reduce the voltage. This is the transformer which is used to reduce the voltage at an output. At an output. Put a heading construction of a transformer. No need to draw the diagram, but I will send you this presentation anyway. Just write what I am saying is, transformer consists of primary coil, in the bracket write down input coil, comma, secondary coil, and soft iron core, Guys, right in front of you, it's written, it's an example of a step up transformer. How can you say that it's a step up transformer? Who will tell me? Remember that if you want that your output will be more than the input, then remember that number of turns in the coil or a secondary coil must be greater than the number of turns in the primary coil. That type of transformer is called as step up transformer. We have one formula in which you can find out the output voltage of the transformer, and that includes the number of turns. If input number of turns, I mean primary number of turns, are less than the output number of turns, it means it's a step up transformer. If input coil number of turns are more than the output coil number of turns, then it's a step down transformer. Please write it down. A step up transformer in which output coil number of turns is more than the input coil number of turns. What about step down transformer in which input coil number of turns are more than output coil number of turns? Guys, my question, you're providing AC input and you're getting AC output. What if you are providing a DC input? What will happen? Who will tell me that? Yes, Safiullah, Armina, what's your point? What if you are providing input DC rather than AC? Yes, anyone? Ibrahim, Armina, Sayyid Safiullah, anyone? Remember that if you're providing DC at input, You will not creating any rate of change of magnetic field because DC provide a continuous electricity. We need a rate of change of magnetic flux or rate of change of magnetic field cutting the conductor because we want to produce uh, induced current or a voltage at output. So if you just pass DC from this coil, this will become a magnet, that's fine. But you will not create any rate of change of magnetic field cutting this conductor, which is a secondary coil. So in case of input DC, there will be no output. So output will be zero in case of input DC. I want you to write one line for this, please. If the input of a transformer is a DC supply, if an input of a transformer is a DC supply, there will be no rate of change of magnetic field lines. There will be no rate of change of magnetic field lines cutting the conductor in secondary. In secondary. So no output is produced in the primary coil.
So what is it after there will be no rate of change of magnetic field lines?
Cutting the secondary coil. Cutting the secondary coil. So no output is produced at the output. So secondary voltage will become zero. So the secondary voltage will become zero. Guys, I will be sending you this presentations. So go through that. And inshallah, in the next class, it will be the last class for this chapter. And then we will simply jump on the past paper questions and we will do the rest of the, the basic, that kinematics and everything through the past paper directly because the time is less. So I don't want to just go through each and every topic in this way. We will do the past paper and we will just complete the things. I want you to quickly go through the topics and if there is any problem, just you can tell me and I will discuss in the class. Okay. Rather than going one to one topic because time is less and your papers are just next week. Your paper are starting next week anyway. So I just want to do some past paper with you so that you will be able to, inshallah, solve the past paper questions as well. For this one, as well as for the classic physics. So I'm sending you right now. You just go through that and inshallah, if there is any problem, we will discuss. Okay. Take care. Bye.